Go over isosceles triangles and the properties with isosceles triangles. So we've talked a little bit about these types of triangles. So in an isosceles triangle, you know that there are two sides congruent to each other. Okay, that was from section 1 that we went over for this chapter. Isosceles, there are two sides congruent. So the parts of an isosceles triangle, your legs would be the parts over here that are congruent to each other. Okay, so one of your legs would be AC. Okay, that segment. The other leg would be CB. Okay, so your legs are your two congruent segments in that triangle. The vertex is the angle that is between those two congruent segments. So this would be angle C. Okay, then your base angles are your other two angles within that triangle. So your vertex is C, so the base angles would be A and B. So we can say angle A and angle B, or if you want to use the numbers, angle 1 and angle 2. So we have an isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. I'm going to use my congruent symbol. Okay, so here I have a picture. So if I know two sides of this triangle are congruent to each other, if I label them congruent, right? Then I can say, again, if those two sides are congruent, the angles opposite those sides. So if I go to the angle opposite this first side here, that would be this one. And then this side here, that angle opposite would be this one. Those two angles are congruent as well. Okay, so if you know those two sides are congruent, your base angles are congruent. Okay, we also have a converse of this, meaning the same thing but backwards. So if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Okay, same thing, but this time we're starting from the angles. So if I know these two angles right here are congruent to each other, okay, those two base angles, then since those angles are congruent, I can go to the side opposite both of those angles. Okay, and those two would be congruent as well. Any questions so far? All right, so example 1, I'm going to mark either the congruent sides or the congruent angles, and you have to mark the opposite. So if I have, say, these two sides congruent, mark on your note sheet which angles would be congruent to each other. Okay, number 2, if I have these two angles congruent, mark which sides would be congruent in that triangle. Okay, and then last one, if I mark these two sides, mark your angles. That would be congruent. Okay, so for this first one, you need to go to the opposite angles from those sides. So it should have been those two. And you don't need to draw in the arrows if you don't have to. For the second one, go to the opposite sides and mark those two congruent. And then the last one, again, from the side to the opposite angles, those two would be congruent. Make sense? All right, so we can apply those two theorems there to some problems. So in each of these, we want to find the measure that they're giving us. So for number 4, we want to find the measure of angle B. Okay, that's this angle right here. Well, in this triangle ABC, I know side AB and AC are congruent. Since I know that, I know these opposite angles are also congruent. Okay? So since angle C is congruent to angle B would have to be 60 degrees. Okay, looking at number 5. We want to find the measure of angle D. Well, that's this angle right here. Okay, I know angle E is 40, and I have these two sides that are congruent. So I know their opposite angles also have to be congruent. So I'm going to mark those. Okay, so angle D and angle F are congruent to each other. Now I'm given this vertex angle. What do all three of those angles have to add to be? 180. So what I can do is take 180 and I'm going to subtract 40 from it. Okay? When I do that, I get 140. Okay? There's two angles that must add to be 140. So I'm going to divide that by 2 to get the measure of angle D is 70 degrees. Okay, so since those two have to be the same, I can just divide that measure by 2. Questions on those first two? Okay, number 6, we want to find side AC. Okay, I know angle B and angle C are congruent, so their opposite sides are congruent. And since AB is 4, that means AC should also be 4. Not too bad? Not too bad. All right, let's go to the back. Okay, so for the problems on the back, we want to find the value of x in each of these problems. So number 7. This is kind of like one of them we did on the bottom on the front. So I have this angle measures 40 degrees. I know these two sides are congruent, so their opposite angles are congruent. Now there's two different ways that you could solve for x here. Since angle Q is 2x, angle R must also be 2x, right? Since they're the same. I know all three of my angles have to be 180 degrees. So I could add all three together. So I have 40 plus 2x plus 2x. And that has to equal 180. Okay, that's one way where you would solve for x. Another way, I can do something similar I did on the front. So I know all three have to be 180. So I can subtract 40 from 180 to get 140. Okay, I can again divide that by 2. Now that's 70. So, yep, one of those angles is 70. So I'd have to set 70 equal to 2x. And x is 35. Yes?
Is it easier just to combine the two x's together in the first place to make it equal?
Yeah, you can do that. So you can do it this way or this way. All right, number 8. So we have these two sides here, and we have these two angles. Okay, angle T is congruent to angle S, so their opposite sides must be congruent. Since those sides are congruent, I can set those two equations equal to each other. So 2x plus 6 equals 3x minus 6. Okay, I'm going to subtract 2x from both sides of my equation. So I have 6 is equal to x minus 6. Add 6. And x will be equal to 12. All right. Number 9. Again, I have two sides congruent, so their opposite angles are congruent. Since y is 3x, z is also 3x. This box up here means that's 90. Okay, all three angles have to add to be 180. So I can take 3x plus 90 and set it equal to 180 and solve for x, right? All three add to be 180. Or I can do something similar that I did in number 7 up here. I can take 180, subtract 90, get 90. Then divide it by 2. That's 45. And then set one of those angles, 3x equals 45, and then I'll divide by 3. Do it this way. Okay, so between those two angles has to be 90 degrees, so I divide by 2 to get 45. Now that 45 degrees is the actual measure of angle y. So I have to set 3x equal to 45. Okay, then I can divide that by 3. So x is 15. All right, you guys do number 10. I'll get adjourned. Yes. All right, so number 10 is similar to number 9. So you could have taken 5x plus 90. That's equal to 180. Since m and o are congruent, both of those are 5x. Okay, or each of these has to be equal to 45 degrees. So you could take 45 and divide it by 5 to get x. And you should have gotten x is equal to 9. Okay. Number 11 is slightly different. So in 11, we're given AB and BC are congruent. So we know angle A is congruent to angle C. Okay, since angle A is 6x plus 6, angle C must also be 6x plus 6. Now angle B is 2x. So we know that all three angles have to add to be 180. So I can add up all three of those equations and set it equal to 180. So we have 6x plus 6 plus 6x plus 6 plus that 2x. Okay, don't forget about that 2x. It needs to be all three angles, not just two of them, equal to 180. Okay, now I can combine like terms. I have a 6x, a 6x, and a 2x. That's 14x. Move up here. I have a 6 and a 6, that's 12. And that'll be equal to 180. Subtract 12 from both sides. We have 14x is equal to 168. Divide both sides by 14. You should get x is equal to 12. Okay, any questions on 11? That one was slightly different than the other ones that we went through. I want you guys to do number 13.
Why is this white? I was confused.
You're the one that doesn't know how to do it. I am the mattress. I think so. I don't know if it's right or not yet. I'm sure it's right. Both of them equal 26 when I'm done with this. I'm pretty sure it's right.
No.
So all you do is 3x minus 13 is 2x, and then you subtract 2x from each side, and then get x minus 13 is at 13 both sides.
That's true.
Yeah, and then we go 0, so we got 13.
X equals 90.
No, it's talking about the side as well.
Oh.
For what? I remember a week ago to look at quotes because I actually like reading. I hate reading. I go there for the wrong.
I don't even know how to read. So.
Now that's sad.
This is a math class.
No,
What words, the numbers,
That's
the
sad. It's like water.
So like, it was yesterday, I'm not even kidding you.
you don't need to know
And then
how
at
to
night,
read
of course, it
numbers.
pops up, and I'm just like, yeah, they
You
make
don't
something,
read
I
numbers
was like,
English class, do you?
All right, so I did pass out your assignment. Yes, it's on white paper because the copier was being
stupid.
mean this morning. So,
I should have thrown here. So you guys
Yeah.
have color paper.
so it's on white paper. I didn't want it to be, but sorry. That's all I got.
I don't
Dip
think
it in
that's how
some
it
color.
works there, but-
Okay, so I just want to go through 13. So in 13, you're given that these two angles are congruent to each other, S and T. So since those two angles are congruent, their opposite sides have to be congruent. Okay? So since those sides are congruent, that means they are equal. So I can set side SR, which is 3x minus 13, equal to side RT, which is 2x. Okay, I want to combine like terms, so I'm going to subtract 3x from both sides. That means I have this negative 13 equal to this negative x. When that happens, you need to divide both sides by -1. So x should be equal to 13.
See, I did it a different way. I got the same answer. I subtracted 2x and then made
And then added 13? Yeah, that's fine.
That was very easy.
I don't feel like doing all that extraness.
That's fine.
I don't like.
Any questions on these isosceles triangle properties?